So is the screen is visible? Yes.
Yes, sir.
Yes, sir.
Yes, sir.
16, 20, 34. Okay. The previous class we have discussed about the line to ground fault we have discussed. Okay. Line to ground fault we have discussed. So today we are going to discuss about voltage sag and voltage swell caused by line faults model developed by using MATLAB. We are going to discuss here. So already you have discussed this week. It is not a problem because we have discussed about what is the sag and what is the swell we have discussed in the class. Okay. So anyone, can you tell me what is the voltage sag? Sag means what? Voltage sag and swell. If voltage is less than 0.9 and greater than 0.9 to 0.1, it is if the voltage is down 0.9 to 0.1 per unit, that is called the voltage sag we have discussed in the classroom. So again here there are three durations. Based on the duration we have categorized into three, that is instantaneous, momentary, and last one is temporary. If the voltage is under 0.9 per unit to 0.1 per unit, for 0.1 to 30 cycles, it is nothing but 30 cycles, that is called instantaneous. We are going to call that is called instantaneous. If it is 30 cycles to 3 seconds, that is called momentary. We have discussed that is called momentary. And if the voltage is 0.9 to 0.1 more than 3 seconds but less than 1 minute, here 3 seconds to 1 minute, that is called temporary. The voltage sag we are going to call here temporary voltage sag. If it is more than 1 minute, then that we are going to call as under voltage. These are all the things under voltage. That one sustainable interruptions we are going to call. If it is going to stay for more than 1 minute, that is called sustainable interruptions. In the sustainable interruptions, the physically, manually, the person has to visit and replace that part. So this is voltage sag we have discussed in the classroom. Just a minute. I have not saved this one. This one, previous one only we have, I have opened this one. Our previous we have discussed. That one I have opened here. This is very much slow. MATLAB is like this one. Still it is loading. I will save as I will do that one. This is actually another model we are going to discuss today here. is saved now. Click on here. I'll write the name of this one. Voltage, sag, and voltage, swell, voltage swell, caused by line fault. It is not visible. Huh? So voltage sag and voltage swell caused by line fault. We have considered this one. Actually, we can enter this one. Okay, no problem. See what we have to consider. So before this, I will make this one. Go for the mouse actually. I'll sit here. See, to check the fault and all the things, first we should have the generation here. First we have the generation we have to get here now. From the generation, whatever the voltage we are getting, that one we have to take here. Okay. So the generator unit we have to use here. So from this one, L1 kV, we have voltage we are going to get here now. After that, so before this one here generation, and here the load is there here. The load, that is RLC load, we are going to use here. RLC load we are going to use. So in between this load and generation, we have to use some buses. We have to use the bus, or for the measurement we are going to call here now. That is not 4 line. This is only okay. So that is 3-phase L1 kV input we got here now. So with the bus we have used here now. From this one we can generate the measurement purpose we can use. Another one, next what we have to use? We have to use a transformer we can use here now. The transformer we can use next middle of that one. And again from the transformer we are going to get 3-phase delta we have considered. Just imagine the output of this one is 3-phase delta we have considered here. Okay, that is transformer. From this transformer again we are going to use the bus for the measurement, that is for the measurement value, and it is connected to the load we are giving this supply here. We are going to go to the load we are giving the supply. So from here we can measure the value of voltage. From here we can measure the output side, output of the transformer, that is this is input of the transformer we can measure here. Somewhere here the line to ground fault, it is going to occur here now. The fault will occur, and that condition, what is it is going to affect to the voltage sag and swell, we are going to discuss in the today class. We are going to discuss here now. Number 39. Okay, so I will erase this all the things. And reset into full screen. Still some papers into 29 members. See here, first I have taken 3-phase source. I have taken here 3-phase source, that is configuration is in the bus admittance, that is generation admittance we are going to use. The generation phase to phase voltage, that is called L1 kV we are going to use here. This is RMS voltage L1 kV, and phase angle is 0. Frequency is 50 Hertz, and this all things you no need to mention, that is base voltage is L1 kV, and 3-phase short circuit level of the base volt ampere, that is called 30 MVA we are going to use. Okay, three-phase short circuit level of the base voltage here. I will click OK on this one. And here, voltage measurement here is that the phase to ground we are using here now. So this one I will consider as phase to phase. That one I think. Okay, phase to phase voltage measurement you can consider. Just a minute, I will run and I will check that one. I have to check. That is phase to phase or phase to ground. I have to check that one. It is compiling now. No output at all. So it came here, output came. So that is not correct. So phase to ground we have to consider. I don't know what it is. It is positive. Once again, we'll check. See here. Okay, this is phase to phase we are considering here now. So that one, the voltage measurement we'll consider that is phase to ground only. We consider that phase to phase choose phase to ground we have chosen that. The main setting we have to do here that is called three-phase transformer. The input for the transformer, what the winding connection I have used, that is the winding one, that is delta connection I have used here now, AVC terminals. Winding 2 I have used again the delta connection D1, that is star connection I was used. Okay, star connection I have used that one. Next we have to go to the parameters. We have to go here. You can check that one per units we are using here now. Units in the per unit or SI units we can use that one. SI units we can use. Just a minute, I'll check it. So we can use where it is per unit. We can use per unit only. In the configuration we'll go that one. See here, first we'll go to the configuration here. Delta also you can use the star also you can use here now. The delta and the star connection we can use over there here also. So we can go for the parameter and go to the parameter. Here units we are using per unit. This it will show the normal power and frequency here now. So 1 mega ohm we are considering here now. 1 is to the 10 to the power of 6, 50 ohm. Okay, and this winding, the transformer winding voltage, that is input is L1 kV, L1 into e to the power of 3, and 0.002 that is called what is resistance per unit and inductance per unit, these two. Next winding 2 we are considering as 400. You can enter 400 or you can enter 0.4, anything, both are current. 0.4 e to the power of 3, you can consider like that also. Both are same only. So magnetizing and this one 5 barabar. Next the load we have to choose here now. So the load voltage 400 we have chosen. Frequency we have to consider, that is Y star connection grounded we have considered 50. Okay, and the active power 10 kilowatt we are using here now, 10 kilowatt, and this one 100 we have used. And these are the measurements we are going to use, that is phase to ground we can use as it is. You can use a label, voltages in per unit also you can use. If you have any laptop you can try also. Simply last time also I have explained, this time also I am explaining, but you have to involve in this period, then only you will understand that. Okay, and here we can give the name also, this one. Select all karne ka, that complete it is selecting. 11 kV bus, we can enter this one. This is 0.4 kV bus, we can enter like this. It is not entered 0.4. 0.4 kV bus. 0.4 kV bus we have used. 14. Consider this RMS value, leave that one. Next, we have to enter the fault. We have to here the IV. I have used one fault system. See out at this measurement block, we have connecting the fault here now. So before the transformer, we'll connect the fault here now. Before the transformer, what I will do, I will connect the fault here. If we have connected a fault here, the transformer winding, I will create a fault, connect here. Previously we have connected at the output side of the transformer. Now we have connected here, and this one is wrong now. I'll connect to the second phase. Okay, so we'll check that one. Once I'll create that is 0.01 to 0.168 we have already given. This is 8. That is 0.1. We will consider here the resistance of that one. I will just check it. And the one phase or two phase to ground will consider to RY, and we'll consider that one. I will run the model. It's running, just a minute. Okay, it is completed, it's running. Yes. See here now, from 0.1 we have considered here now, 0.1 here, it has started to fall here now, voltage sag is occurred here now. At this point, just a minute, I'll consider here. See here, this is the input side. I'll use another color better option. Which one I have to use? Green color, all colorful है. इसको थोड़ा highlight करता हूँ एक मिनट. Styles we have to go. See here, the R phase and Y phase we have considered. The fault we have considered. R and Y I will use. The second active, that is called yellow color. We have used that one. I will use. Apply. Here it has applied. Okay. So from this one, it is taking only one color only. Bus 2, yellow here consider. Okay, that is 0.2. Apply. Okay. Next bus 3, L1 kV. That is also I will make that one. So darker line it will be visible for you guys. Okay. So now I will use the green color. I will use better option. Okay. See here, from 0.1 to this one in this period up to here, the R and yellow phases, they are, the voltage is reduced here now. The voltage is reduced, and the blue color is there. It has higher voltages. That is called swell. We are going to call that. That is called swell. Udhar malum nahi hote, but the output side you check here. So this is light increase in the voltage here now as compared to this one. Here the higher voltages are there here. This is called swell. We are going to call this one. Whatever these voltages are increased here now, this is called swell. We are going to call. This is swell. And whatever these phases are reduced here now, the output side. See here, yellow line, this blue lines, these are reduced here now. These are affected by the fault here now. So they have reduced their voltages. That voltage reducer point we are going to consider as, that is voltage sag we are going to consider. Voltage sag and swell both at a time we have derived here. This one for two phase to ground we have considered here now. Two phase to ground we have considered. Just a minute. I will take one single phase wise. We will consider that. But no color it is changed. This color I will change that one. Just a minute. Second one, this style color I will change. First one is the red color, na? So red I will use. Style, that is the second one. Second one, that is 0.4 bus 1. That one 2. That is R. Apply. Next bus 2. 2. Yellow I will consider. Same we will consider. Then it will be easy. Next bus 3. Take 2. Blue you consider. Blue consider CN. So here also R and Y phase we have considered. This is input side, we have created a fault here now. Before to the transformer we have created a fault. Then same thing we have applied that one. Just one, it is instead of 0.4 we'll set 0.2 time. That is execution time we are going to call. And instead of two phase I will use only phase A. One by one will run that one. One by one I will run that one. Instead of this fault resistance 8 ohm, to consider that is 20 ohm here. 18 or 16 ohm and 0.1 is the ground resistance. You can check here. That is one phase. The fault is cleared. So execute here. It will run here. So the here only for the R phase you see at the input side the resistance is fault resistance is very high. We have used it, that is 18. So for that reason what will happen? There is no much change here now. What is the fault? 0.1 here now. The condition, I will just a minute. The fault I will, where we have set it that fault 1 0.01 0.01 to 0.16 we have considered. So according to that 0.02 is there, 0.01 it should have to start here on this here. The fault is occurred at this point. There is some what is that one? So morning we have considered that this one. We have said this one. What is that one? The name we have used. DC offset, interruption, inter-interruptions, notching, na? Yes or no?
Yes.
Notchings we have done here now. For particular where the fault occurs, the switching will be occurred over there. The notching is placed here now. And exactly you check that one. The output voltage is exactly other phases voltage is here. And the R phase is little bit down is there here. It is down. Down is there or not? This way. And here you consider here now from Y B phase and that you can consider that little bit changes there actually. So exactly straight line I'm not getting here. Here. It is a little bit the sag is there, voltage sag out. Bolo madam. This is for one phase. Any one phase we have applied the fault we have applied for one phase here. Suppose what I will do, we can change the phases here now. So instead of here, I will use here. Then you can set that one here. Okay. I can the fault I will use instead of A, I will create a fault here and I can change this resistance into 2 ohms and the point, the fault timing also you can change here now. Instead of 0 0.01, 0 0.04 and this is 0 0.092 I will consider that. Okay, so I will enter here now and I will run the model now. We'll run the model. Just check it. See it. The resistance I have changed the value. Phase A also it is varying here. The input side here. See here, the notches is produced for phase A. Both I have considered. I don't know about that one. Just a minute. Now, phase A, B only we have considered here now. But then also the other phase, it is affecting here. The fault is input side. That is affecting to the other phase also. You can observe here. You can observe here. See here, the flickers here, the flickers came here now. The blue line also the flickers came. This one. You can check it. You can check it. Slowly, step by step also you can do that one. You can play. See. Actually, for the phase B, we have occurred, the fault will be occur, but the flickers are coming here now. This is voltage swell we are going to call particular for the voltages. If one phase, one line we have occurred, the this is the downside is there, voltage will reduce us for this phase here now, the one phase that is called voltage swell. And here, this is flicker, sorry, what is notches and also the voltage is increased here now. Comparing our level of voltage is here, up to here only we have to get, but the voltage is increased over this particular value. Here also you can check that one. Here the voltage is little bit small increase is there in this one here. That is called swell we are going to call, and this one it is sag we are going to call that one. Voltage sag we are going to call. I don't know why it is taking for the just a minute. Sort it out. For the first A phase also it is taking. For the first phase, initial value phase to ground, and it is completely run or not. Here some flickers are there. Only some flickers are produced here now, the input side, but our voltage, there is no change in the voltage here now. The B and whatever that is, R and B lines, that is phases. But the yellow phase, phase B we have applied. The yellow line indicates the phase B here. Audible hai kya nahi? Is it audible? Hello?
Yes, sir.
Okay. So this is voltage sag and swell we are going to call that one. So we can check the output by considering the RMS value also here. So this one actually the 3-phase voltage it was shown over there. I have considered one. It is converting into RMS value. It is going to convert that one. Okay. So what is that one here? Running RMS value it is going to do that one, find RMS value over each column here. Now we can click on that. See here now, the R phase, whatever that one, the fluctuations occurred here, and particular the time period we have given 0.4 to 0.09. 0.09 is nothing but 0.96 is nothing but 0.8 only. Na? You can check the timing here. See here, the fault timing is 0. Start timing is 0.04, end timing is 0.09. 0.09 is nothing but that is 0.1 only. So based on that, we have to get 0.1 here now. Up to here, the fault is voltage. It is some fluctuations occurred here now. The fault is occurred here. That line it is showing here. This one also I have to change. That is yellow line only I have to consider instead of red. Then you will understand that correctly. Yes, see here, this is the input side, whatever we have considered. This is the output side. The fault occurred at the before the load, whatever the input side of the transformer, then also it is going to affect to the customer side here. This is the customer side, this is the generation side. So generation side fault occurs, it is going to affect to the customer side also, it is going to affecting here now. And some notches are produced here now. See here, so voltage should have to maintain constant value here, but it is not falling. This is the RMS value of that again. RMS value we are going to consider. So instead of this phase B, I will consider phase A and B here now. Now we have separately we have done the fault here now. Now I will add both A and B phase. I will create a fault here. Create a fault. Run the model. See here, the R and Y phases, the voltage is reduced here. The fault is occurred at 0.04 the instant, and the fault is cleared at 0.09. That is nothing but 0.1 time here now. The seconds we have considered here. समझ में आ रहा है क्या नहीं? Hello. Rule number 1, are you there?
Yes, sir.
समझ में आ रहा है क्या?
Yes, sir.
कैसे आए फिर आउटपुट कैसे आए मालूम हो गया क्या एटलीस्ट? I don't know, you will draw this diagram in your computer and all the things. I don't know about that one, because you have to search the equipments here now. 3-phase source, you have to go to the library. Okay, go to the library. You can go to the Simscape here now. Where it is, Simscape. Here you have to go. It is not selecting. From here, you have to choose power system blocks. From here, you can go for Simscape components, control, measurement, renewable, fundamental blocks. You can go over there. And here, electrical sources are there. Again, you have to visit. See here, 3-phase source is there here. We're getting the 3-phase source here. Right click on that. You will add your model here. Now it will comes to the model. It will comes. It will take some time. We'll wait for that. I have set the value. See here, it came here. It came here. This block is 3-phase source. This one and this one is same here now. We can check the values here. You can check L1 kV, 50 hertz frequency. We have set that 30 mega volt ampere we have set it here. But here, you can check here. The values are same or not here. See here, how much it is there? 25 kV is there. Voltage is 25 kV they are using here now. We have to change this type of values. How much input generating we are doing? L1 kV. What is the frequency? 50 hertz we have to do here now. Enter here now. Other things you can keep as it is. That is not a big issue over there. So the base voltage, that is phase to phase, that is how much it is? L1 kV we have to enter here. L1 kV we have to enter. Here also we have to change that one actually. Base phase to phase, that is L1 kV. We have already changed that one. So previously we have changed that one, and instead of 30 mega ohm, that is 1 mega ohm also, 1 MV also, we can do that one, the generation here. So like this, you have to take the blocks. Some other systems are there. By clicking on, go back here, electrical sources is over now. Power electronics measurement here now, voltage current measurement, you can take this one. Three phase VI measurements, you can take that one. Current measurement is there, impedance measurement is there, voltage measurement is there. You can. But sir, take a minute. Okay, like this, you have to take the all the components you have to take from the library one here. Current measurement, impedance measurement, voltage measurements are there. So we are working on three phase. You have to just right click on that. You have to add model to. I have saved this file as MSY PQ sag and Swell here. Like that I have saved. You have to check that one. Okay. So if the same fault again, I will apply the two faults, line to line faults. We are going to call that again. I will rotate this one. This part. We can do some what is that one? See here, I will make this one into the A fault. I'll go where it has taken here. Okay, the B I will connect here, and C I will connect here. Now I'll give the different times. I will give different times. I'll give again. I will choose same, but the timing is 0.02 to 0.06. I will give here now, and the fault resistance is 4 ohm. I will give. Can connect here now. Okay, I have not applied, so it is not going to take that. Save directly. Okay, no problem. It has taken here now. So what I have to do, I will run now once again. Check that one. What will happen? It will check that one. Check the scope. This one. See here now. Completely for the two faults, the voltage is completely how much it is there? 0 is there. It is completely 0 or not? Hello. Hello.
Yes, sir.
So the voltage is completely came to 0 because the two faults occurred at a time. The full two faults are occurred here. So here at the output side, because of this electromagnetic principle, the transformer, because of this phase, one phase, it is going to produce the output here. But it is very less voltage it is going to produce here. We have to get 300, we have set it here now, but we are getting how much it is. That is not 200 also here. The voltage is reduced, and especially for the phase A, it is completely 0 is there here. It is completely 0 here. This one actually we will discuss in the next week. We will discuss that one. This part occurring we will discuss in the next class. So that is double line fault. We'll consider that one. We'll discuss in the next. So only our aim is the RMS value, how we have to show, and what is the fault. It has occurred here now during 0.4, 0.2 time, and 0.1 we have given here now. Based on that, if the fault occurred, how the sag is occurring here now, voltage sag, and how the voltage is increasing here. We have to show. That was the intention. I have shown here. We can practice. And all the people's other class students, they are coming to the college. You people are still in listening mode only. Still in listening mode only you are there. So as soon as possible, you practice these all the things. This subject, it doesn't have any, what is that one? Oral exam, only practical oral examination is there for you peoples. Practical oral examination is there. What ground resistance is 0.01, I will consider. So this is the variation. Any doubts here? Anything you want to ask? Or you will you do this model? I told you have to go to the this one library. First click on the Simscape and go to the power system. In this power system, specialized technology you go, and here fundamental blocks. Then you go for the electrical sources. You will get the source here now, and come back again. Here you go the measurement. You want to measure anything, you can take the measurement block here, and again you have to go for the elements block. You go struct here only. Okay. From this one, you can take the load. You can take that one RLC load. This one 3-phase series RLC load trans. You can take the transformer here. The transformer is there here. 3-phase transformer, 2-winding transformer. You can take parallel RLC load is there here. All the blocks you got here only. This is measurement. This is load and transformer you got here only. Okay. You can take this all the things, and you have to set your value, and you have to join that one. Up to all the things are here only. If you want to anything, you want your machines and all the things you want to perform the practical, then also you can add a single machines also here. Steam turbine governor you can add here now. Switched reluctance you can add here now. Synchronous machine fundamentals you can add here now. All the machines are there. Excitation system is there. So you can do everything by using the MATLAB. Will you do that? हेलो, कोई तो रिप्लाई करो. करते क्या इसका आउटपुट? This subject has, I told, oral examination is there. I am going to ask the questions, oral questions based on this one. So everyone of you people have to remember this one, and you can, I change the fault resistance now. Instead of 6, I will give. Run the model. The resistance will also, how much resistance fault is offered, that is important here. So little bit I have increased the resistance. It is changed here now. The values are changed here now. Instead of this, if I use around 20 ohm resistance, then what will happen? We'll check that. Okay. Some materials came, so the computers, new computers are coming to our department once again. So if you have any doubts, you can contact. Otherwise, we'll stop here only. Any doubts? मुड़े, are you there? Unmute करने के लिए होते क्या? देखो एक बार. हेलो, नहीं हो रहे. श्रद्धा?
Yes, sir.
हाँ, कुछ डाउट है क्या?
Huh?
Any doubts?
No, sir.
Okay. So you practice it, and in the last previous one and this one almost same only are there. Okay, we'll check that one. So I will stop here only, and we'll continue in the next class.